Alrighty. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. RCW, good to see you. Good evening. Xerox and Enigma Dev. Man, I can't talk tonight, apparently. Xerox and Enigma Dev. Hello. Welcome. How are you guys doing tonight? Mean Mr. Mustard, good to see you as well. Hope all is going well. So, as we can see here on the screen, I just kind of tied up what was remaining on textures. So, we are actually going to move on to something different tonight because we actually have textures up and running. So we'll touch on that in just a second. But I just wanted to kind of bring that up for a quick visual update for you guys. Yes, we are finally done with the texture resources. Yeah, and that was the most wide-reaching of the resources. So the others theoretically should be faster. Faster to get through anyway. Thought we'd be stuck when doing that for at least a week. Well, I mean, it probably was about a week, honestly. I mean, it depends on how you track a week, right? Before we get into that, though, I do want to take just a quick second and thank the supporters of the channel, starting with our partners. They are Furkan Token and Gerboles Inc. I would also like to thank the supporters listed here on the screen as well. They're a combination of the other tiers of support over on YouTube memberships and Patreon. Of course, I would also like to thank all of the viewers, whether you're catching the VOD after the fact or whether you're here live and joining us on the YouTube side or the Twitch side. We do simulcast to both. This is designed to be an interactive stream, so feel free to hop into chat, and we will chat, as I've been doing thus far. So, Smudge, good to see you. Welcome. Let's see. Okay, so, yeah, I guess we should probably recap as to where we actually stand on this. So, the big things that we have to knock out, textures are done, right? So that was definitely the biggest and most wide-reaching one. And I think that's probably the only one that is going to affect our Vulkan backend, I want to say. Meshes might, but I don't think so. So we have materials, which is what we're going to hit next. We're going to start on that tonight. We have our static meshes. So right now they're just called meshes. We're going to rename that to static meshes because we're going to have another resource type here shortly that is not a static mesh. We need to do the terrain, which we're going to rename to height map terrain because we're going to have more than one type of terrain. And then we need to do shaders, and then we need to circle back to fonts and I feel like that can't be it, but I think that is it. Other than, some of the other simple ones like, text files and stuff that aren't really in use. But yeah, tonight is definitely going to be, we're going to focus on materials. And with that, we are going to enhance materials. So we're not just going to do a straight up transfer over to like the new K resource materials. We're actually going to revamp how our materials work a little bit and make them a little bit more flexible, as well as add some known properties and known types of materials and structure that stuff out. And you guys will see what I'm talking about once we get into it. But we do have everything for the most part back working again. We can see here that our Sponza is good to go. Our shadow map's fixed. Our water is working again. Everything is pretty much up and running again. So with that, we're definitely in a good place to go ahead and move on to the next type of resource. Now, I should also mention that once we get materials and meshes done, then we're probably going to go ahead and start jobifying the asset system first, and then maybe the resource system after that, aka multi-threading it. So, we'll probably stop along the way to do that, just to make sure that that's all good before we tackle the other systems. All right, I hope that makes sense. Did you study physics and math to start developing the game engine? Math, somewhat, yes. At least what I needed to know for this stuff. Physics, kind of on a cursory level. I certainly haven't written like a full physics engine on our own, right? And we may or may not do that. I still haven't decided yet. That might be one of the areas where we don't write that from scratch. But yeah, I mean, in terms of math, it's like mostly just linear algebra stuff. Will it be easier using the threading system you added in 2022? So we actually already have a job system that utilizes those threads. The job system's been in for a very long time, and it works just fine. We're going to leverage that, actually. And there's not going to be any refactor needed for that whatsoever. It works fine as is. The other thing that you'll notice is I got rid of all the validation errors and shutdown. So the fixed version of all this stuff is already up on the repo under the feature kpackage branch. All right. Smudge with a 5-stream streak. Awesome. Appreciate that. Okay, so when we're talking about materials, this is what our current material structure looks like. So we basically have this sort of nebulous ID, a material type, which we're not really utilizing, right? So if we go to material type, actually, right, we have some of these types which actually don't even make sense anymore. So obviously we have the invalid unknown type, right? We're gonna maintain that. We have a PBR, and then we have something here called a terrain, which is really just a special type of PBR material for terrains, right? To allow us to sort of blend multiple materials together. We might actually wind up removing that as a concept, right? And just sticking with PBR materials. And then we have this custom, right? And so one thing that I want to do is I want to actually bring back, we had a Fong lighting model, and I want to bring back a couple of other material types. And most of those things will be based around sort of the lighting model that it uses. So we'll have Fong, we'll have PBR, we'll have Unlit, which is another one, and maybe a couple more, right? But those are the biggest ones. And so when we start thinking about how we want our materials structured, we're going to have sort of a base K-resource material that is going to then provide a type. That type is going to tell us what structure to cast that base material into, and then that will give us our specific properties, right? So some of these things that we have, like generation, is actually going to be embedded in the resource, like the base resource type, so we don't need that anymore. The internal ID is we're probably going to wind up calling that something else, like a renderer ID or something like that. So we're gonna redo that as well. The name and package name, obviously, those are going to be embedded in the core resource, so those are going to go away as well. Our texture maps here are just going to move over as is. And then this whole property structure size thing is going to be going away, along with the properties here. That's going to be replaced with material-specific properties, right? And then we have this sort of this texture here for an irradiance texture. And I think that is probably going to wind up turning into a texture map as well, right? And that's also going to be specific to the type of material that we're using. And then also we have this shader ID down here. I'm not sure that we're even going to need that anymore. I think we're probably going to get rid of that as well. And so as an example, like we have these commented out properties in here. So we have diffuse color and shininess. Those were sort of for the Fong model. So we'll bring those back as part of the Fong K-resource material, right? And so what we're going to do is we're going to start there and just kind of work out what the structure is going to look like first. And then we're going to go ahead and sort of rebuild everything around that. So K resource types is going to be where we're going to start. And we already have a type in here for material, so that's what we're going to use for that. And I believe all we're going to do is something simple, or similar rather, to how we did textures, right? So we're going to have a sort of base material that's going to include base, right? And then obviously we'll have other structure types that'll sort of cascade down from that. Dr. Elliott, how's it going? Good to see you. Let's see. I actually remember where I was the day you started the threading system. It was one of the craziest days I've had. It's weird how like memories line up with stuff like that, isn't it? Okay, so we are going to go down to the bottom, and we're going to type def a new structure, and we're going to call this K resource material. Right? And this, of course, like the texture itself, is going to have just a sort of K resource base in it, right? And then it's going to have a material type, which we haven't defined yet. We're going to define a new one, right? So we're going to say type def enumeration K resource material type. Material type, right? And we'll do K resource material type. Let's see. Should we have an invalid type, or should we just say, you know what, unlit is sort of the default? Which will obviously require us to write an unlit shader, but maybe that's the way to go. I'm not going to do that for right now, but we might switch to that, right? Just to have the default as that, unknown. It should be type unknown, right? So we'll have unlit material type, and then we're going to have fong material type, and we're going to have PBR. And then what we're going to do is for our, let's see, we also had this concept of, with our old material types, this concept of a terrain material, which is really just a mixture of like up to 4 materials, right? Up to 4 PBR materials in our case. I think we should eliminate that as a concept and only have materials like this, like what we have here. And then what we could do is maybe have a flag where we can have sort of sub-materials, right? Maybe. I don't know. We'll cross that bridge when we come to it, right? I just kind of want to get this out for right now. So let's do K resource material type, and we'll have type. And that's all that's going to be included here, right? That's it, at least for now. We might have like some flags or something, but the flags might wind up being type specific, so I'm not going to put that in there yet. Okay, so what do I mean when we're going to have like different sort of cascading types of materials? So what I mean is we're going to actually type def a structure, and we're going to say this is a K resource material. And we're going to say unlit, right? K resource material unlit. And what this is going to have is it's going to have a K resource material. Should we call this base? I guess we can call it base. I don't really like that because then we'll have base.base to get to the resource, but I'm going to call it that for right now. It's good enough. All right, so in other words, what this is going to allow us to do is by having this stacked this way, we can cast this structure type to a k-resource material, or we can directly cast it to a k-resource, because that's always going to represent the first bytes of the structure, right? And it just sort of cascades down. And then we add, the sort of specific stuff. So in this case, we might have a k-resource texture map. And in this case, we're going to have let's call it a diffuse. Right, just a diffuse texture. I thought it was k-resource texture map. Oh, I have to include render types. How did I get away with that over here? I think, did I forward declare that for this? Let's see. See, we also have these weird things like material fung properties, material terrain properties. Like, I want to get rid of all this kind of stuff. Yeah, we forward declared it. I guess the k-resource texture map really should be in this file. What was the reason that I had put it here? Let's try removing it. And we'll put it, I don't know, here. I think it had something to do with fonts, if I remember correctly, but let's build this real quick. Maybe it'll be fine. Looks like it might actually be. You know what? Let me clean and rebuild. We might actually wind up being fine. Okay. All right. So k-resource texture map is now over here. So this particular unlit, right, should have a, I guess we should call this diffuse map. And then also a vector for diffuse color. Right, because unlit materials should be just basically diffuse, right? They don't accept any sort of normal maps. They don't need any specular maps or any of that stuff, right? They're unlit. They don't receive lighting information. They don't receive any of that stuff. The only thing that they have is a color and/or a color map, right? And then we would next have type def struct k-resource material, and I guess let's do Fong next, right? So this is kind of a harken back to the beginning of the series where we use Fong maps for everything. Material Fong, right? And the reason is because we might have a scenario where we don't need PBR materials for everything, right? There may be situations where it's like, okay, well, you know what, an unlit texture is good enough, or a Fong texture is good enough, or material rather, and then I'll save us on some performance, right? And there's no reason we shouldn't be able to mix and match that. So we're going to make this a lot more flexible as is too. Let's see. Any opinion on DirectX 11 versus OpenGL? Just like hearing opinions. I usually steer towards OpenGL between the two, simply for cross platform compatibility, right? DirectX 11, you're limited to Windows and Xbox, basically. Versus OpenGL, you can support cross-platform. If you don't care about that, DirectX is a nicer API, I think. But yeah, outside of that, I don't really have too much of an opinion on either of those things. We're going to be doing DirectX 12 at some point here in the future as another backend. And we'll also be doing Metal for Mac OS. But yeah, OpenGL, I don't know if we're going to do that. The only problem with OpenGL, obviously, is it's deprecated, right? But then again, DirectX 11 is also outdated, right? I'm not sure if that's the opinion you were looking for, but that's the one I have. All right, so you found DirectX 11 easier to learn than OpenGL? Really? I think OpenGL is a little easier, personally. Came home from a week-long vacation. You were so tired and distracted you left your suitcase on the train. Oh, dude, that sucks. Immediately noticed it, got back on the train to find the suitcase, but the train took off with you in it. Had to spend 2 more nights in a city 2 hours away from you. Oh, man. That does suck. Alex Lee, thank you so much for the nice words. I appreciate that. I'm glad you find this series helpful. first time chat. Pro tip, never argue with a dinosaur. You will get your ass kicked. That's excellent. And just in case it's not like super clear, let me take a screenshot of that and bring that over, because that's deeply hilarious. Yeah, that is a really good one. I appreciate a good dad joke. So yeah, that's a really good one. I like that. Not bad for a first message. Excellent. Apotham, how's it going? Welcome. Good to see you. Pretty sure Mac completely dropped OpenGL support. I know they've deprecated it. Dropped, I don't know. But I suspect what's going to happen there is what is going to happen on Windows or any other platform, if it hasn't already, which is that they'll basically just build a translation layer underneath the OpenGL API to something else. Yeah, I think they just deprecated it. I don't think they dropped it, but what they more than likely did was they just wrote a metal layer underneath of it, and they're just translating API calls underneath, if I had to guess. Yeah, no big deal. Yeah, I didn't, because that would break an awful lot of applications if they were to just like completely. Yes, that is true. There is no version support over 4.1. So yeah, like if you try to use anything newer than that, then you're out of luck. But there's so much legacy software that was written using OpenGL that they would just break a lot of stuff. Rough day for me today. Car problems, nothing too serious. And just annoying having to wait. But besides, I'm doing good. How are you doing? Oh man, that sucks. I understand the car problem thing. Sorry you're going through that. But yeah, been there, done that, got a dresser full of t-shirts. For sure. I am doing well though. Thank you for asking. OpenGL just hides too much in my opinion. Can you even create a swap chain with it? No. Yeah, I mean that's the thing. That's the thing I don't like about OpenGL. It's easier to pick up, but like once you want to start doing advanced things with it, you don't really have the control that really you should have. All right. Do you live in the north or the south? I live in the south. Okay, so Fong actually had these two properties. Let's see, where was that? here we go. So we had these two things, properties that were old Fong properties, and for some reason I commented them out and never removed them. But there we are. All right, so we have diffuse color and shininess, right? So the diffuse color, again, is used in Fong, right? And then we have shininess. And then we also have, so our shininess basically determines how like concentrated the specular highlighting is. So we have that, and then we're also going to have our maps as well. So we'll have K-resource, texture map, right? We're going to have one for diffuse map. We'll have one for specular map. And we'll have one for normal map. We could also technically support emissive on this. So I suppose we can get that in there too. Right? And so each one of these could probably also have associated with it various properties, right? So diffuse color kind of goes up here with the diffuse map. We can also have, I guess specular color is kind of based off of the light color. At least that's the way we wrote our Fong setup. So I'll probably leave that one alone. Normal map doesn't really have anything. Emissive map. We could also do an emissive color, but I don't think that really makes sense. So I guess really this is the only one that has that. And then let's call this specular shininess, right? I think for Fong though, that's probably about it. Yeah. And then what I'll do is I'm actually going to take this and we'll use that sort of as our template for our PBR. So we'll just call this PBR. And again, PBR is going to have diffuse. This is actually going to be instead of diffuse, we're going to call it albedo, right? And I think we can just put that in here. Albedo. We don't have a specular, but what we do have is a metallic map. And then to go with that, we have a roughness map. And then we have a normal map, and then we also have an emissive map. And I think those are going to be what we're going to have, is these 5 maps. Now, with that said, there is something to consider here, where these 3 right now in the material system are kind of combined into one map. And the reason for that is because we only really need a single channel of data to go with these, right? We don't need like RGB data for any. Sorry, not normal map. There's another one I forgot. It's AO. Right? So let me move the normal map up here. It's these 3, sorry. So metallic, roughness, and ambient occlusion map, right? We only really need a single channel of data for all 3 of those maps. So those internally are mapped to what we have called a combined texture, which we were actually creating in an external tool, and then importing as one map. We're actually going to fix that, and we're going to set it up so that these things can actually be configured with separate texture files. and we'll just combine them in code. And the advantage there is when we go to like edit it in an editor, we'll be able to point these to different files. So that's kind of what we're looking at. Oh, ads. It was about 10 seconds late on the ad. No, I was about 20 seconds late on the ads. So I will just, I'll kill that timer a little early. Let's see. That's brisk, baby. Yep. I will catch up on chat here in just a second. I'm just waiting for the ad to complete. So we've got about 20, 22 seconds or so left on ads. All right, I'm gonna go ahead and switch back because ads should be dead now. Let's see, what other books do you read these days besides game engine architecture and real-time rendering, which are the two I normally talk about? Let me see, I haven't actually read any like books per se. I normally read like online papers and stuff like that. And of course the Vulkan spec. But yeah, books per se, I haven't really read anything other than, do I have it in here? I have been reading this book a little bit, which is, I don't know if you can read that. It's game physics engine development, right? So I've just been doing a little bit of reading on occasion about physics engines. So there's that one, and that's game physics engine development, and that's by Ian Millington. So that's been a pretty good book so far. I think it's worth it so far. I think it's also going to be one of those books. Cool. All the rest of my books fell over. It's also going to be one of those books that I'm going to have to read probably multiple times before I get all of it. So it's pretty information dense. Yeah, mean Mr. Mustard. That's not wrong. So yeah, that's pretty much where I'm at on that. If I were you, I'd continue working on the Z game at the moment the moment the refactor is over until you run into a missing feature. That way you know better what features it would need. So we've actually already kind of got that list because we kind of stubbed out some of that list in the design discussion that we had. So this refactor is the big one, and then there's a couple of smaller features I need to add in there to at least get that game started. Added to my book list, thanks. Bought the game engine architecture book, can't wait to continue reading it. Yeah, and that's going to be one you're probably going to want to read a couple of times as well. All right, let me catch up on, let's see. Why type struct in C++? This is C. Oh, your brain is wrong. It says C, yeah. Literally saw C++. I should really sleep. That's fair enough. Status line is what messed you up. Yeah, I don't know why it detects header files, like H files, as CPP. It really shouldn't. Because it's C, but I guess it doesn't really know the difference. Speaking of those two books, did you read them like a normal book, or do you just use it for reference? I read them like a normal book, and I use them for reference. So, yeah. Both. Physical copy, yes. Prefer my books in dead tree format instead of digital. I am the same way. If I could get the Vulkan spec printed and it wasn't updated every 6 months, I'd probably do that. Because reading that is painful. The only advantage to the Vulkan spec being digital is it's of course searchable, but do Do you think there's any benefit to building a 2D engine to learn engine architectures, graphics programming over 3D? It's an ongoing debate I'm having. So that's a good question, actually. So I would say if you're thinking about writing your first engine, go 2D. There's nothing wrong with that, right? Really, it's just going to simplify things. You don't have to deal with the z-axis for one. You don't have to, everything's minus one axis, right? So it becomes simpler to handle a lot of things. Rotations are simpler, for example. So yeah, there's definitely benefits to it, because you can, everything else pretty much applies, right? Every other design decision that you make pretty much applies. You'll be using quad trees instead of oct trees, for example, but like that's minor stuff, right? So yeah, I mean, for practice writing an engine, there's nothing wrong with doing 2D. In fact, you'll probably get further quicker with it. So yeah, I would go for it. If you've got something in mind that can actually use that, then go for it. I used C for 10 years, only recently switched to the dark side, C++. Yeah, I mean, I get it. I had to use it for work, right? But most of my C looked a lot like C. So when I went to set out to do this project, I'm like, you know what? I'm going to write it in C. Honestly, everything is 3D now. 2Ds these days is 3D with isographic projection. I do retro stuff, so I use a pixel buffer. Yeah, so I mean, you can do it that way, or you could just not use the depth buffer and accomplish the same thing. And then draw order is how you layer stuff. Which is how I would do it in a 2D engine. Yeah, if you use new delete malloc free, it's wrong. Yeah, well, I mean, it depends, right? As with everything in programming, it depends. There's no absolution for everything. Except that there's no absolution for everything. That's the only absolute. It's kind of like saying the only real constant is change. It's kind of the same thing. Ryan Fleury has a really good talk on manual memory management. Yeah, I'll bet he does. I don't think I've seen that one, but we have our own memory management in this engine too. Hence the quotes. Yeah, I figured as much. Yeah, I feel the same way. It depends. Been in the game since Pascal days. Nice. I remember Turbo Pascal. Not exactly the same thing, but I know what you're talking about. My engine is in 2D since I don't really have any feasible game ideas for 3D. That's, yeah, totally reasonable. Negative pointer you learned with basic. I learned QBasic. So yeah, dating myself again. Let's see. Millie, hello. How's it going? Reading more C engines lately, including yours, and I've been enjoying how simple things, everything feels when reading. I've honestly considered jumping ship to just using C. That's one of the reasons I use it, for sure. Would you think it would be too stupid to refactor my use of few template functions, lambdas, vectors, for my own implementation in C? I don't think that's stupid at all. Give it a shot, right? If nothing else, it'll be a learning experience. Do you teach game programming? Not directly, sort of indirectly through the series, I guess. This is an educational thing, so kinda. 6:43 in the morning in India. Yeah, it is early over there for you guys, huh? Cool. All right, I think I am mostly caught up. Let's see. Awesome beard, by the way. Thank you for that. I appreciate it. This is about a year's worth, I think, at this point. Been learning Pascal in 8th grade about 8 years ago. How old are you all? Surrounded by a bunch of programming unks. Yeah, I'm definitely boomer level. No, I'm gonna be 40 next year, so there you have it. C is great to learn how code really works. In my opinion, it makes you better at other languages. I say that all the time. I couldn't agree more. Learned COBOL first. Still think I'm a little angry at my dad for that. I actually had to write COBOL to interface with a old HP 3000 system, retail system, at a previous job. I had to learn COBOL and write an interface on that to interface with our system. That was interesting. C is the perfect language to learn with, in my opinion. Yep, it's simple, but also reinforces a lot of... it reinforces and forces you to learn a lot of low-level concepts. 38 here, nice. So we're basically on the same page there. Whenever I see people write C# code that pluses strings in a tight loop, I want to curl up and spontaneously combust. And or vomit, yes. I agree with you. What's the time there in America? So I am Eastern time, so it is 9:15 p.m. But yeah, there's 4 different time zones here, so it depends on where you are. Do you play any games that inspire you to continue programming? Not directly. I do play a lot of Grand Theft Auto 4 these days, and also Final Fantasy 14, which is like completely different ends of the spectrum, I know. But usually I play those for, different reasons, but they also do motivate me to like, man, it'd be really cool to get something like that in my game. All right. Missed a question about INI files. Let me see. Where is it? It must have been further up. Where is it? Your beard looks very magnificent. Thank you. Mean Mr. Mustard. How long ago was that message? I must have... Oh, there it is. INL files. I don't remember if I asked already, but why do you use INL files instead of C files in the render system? I think we got rid of all the INL files, actually. I originally had used those as like the only header files that I wanted to include other header files, or to be included in other header files, but I decided eventually that was stupid and got rid of them. For me, Hollow Knight really inspired me to dive into game programming. That's fair, yeah. Let's see. Same. Love C because I get to think closer to the machine. Learning more about data-oriented programming is a ton of fun to unlearn old habits and establish paradigms. Yeah, I'm still wrapping my head around some of that stuff myself, to be completely honest. Stopped using C because of unique pointer and RAII makes things so much easier. See, and I specifically don't use RAII, but that's just me. At this point I have C down, so using it isn't getting me any further. That's fair enough. Though C++ only really got good at C++ 20, and I've never used anything newer than 17. Most of what I've done is 11. Daggerfall is what got you into game programming. Old school, love it. Animal Well is another good game to be inspired by. I don't think I've seen that one. I'm going to open that on a different tab and look at it later. All right. C++ has a neat feature coming up, STD breakpoint. Oh, it's like typing debugger in JavaScript, basically. Does exactly what you think. Yeah. Which, I mean, is cool, but I can also just... I can also just do that. Fair enough, though. All right. Anyway, I should probably get coding. Okay, so where were we? Yeah, stop reading chat. Yeah. At least for a couple minutes. I do like chatting with you guys, but yeah. I gotta code at some point. So let's see. I'm just trying to think of all the stuff that we have here. So metallic map, roughness map. So these are almost in a way opposites of one another. AO map, so we have to find a way to combine these, and then we have emissive map, which we don't have support yet, but we're going to add that. The other thing was the irradiance texture. So we're going to call that irradiance map. Okay. Do we have... Oh, we don't need that. So I'm trying to think if we need any other properties besides this, but I don't think so. I think we're good. Now, there is one other thing I kind of wanted to talk about, though, which is the way that these maps work in general. And this is maybe something that we can do in a future pass, but it's something to think about. What if, for albedo, we wanted to specify a color, just like a flat-out color? Maybe that color came from... maybe the color came from a texture, right? So maybe it's a texture map, but maybe also it came from, a function somewhere. Or maybe we just specify it directly in the material configuration, right? Technically speaking, any of these should be able to accept a color or a texture, right? So ultimately, when we sample, like an albedo map, we sample RGBA. When we sample a normal map, we sample RGB. We technically leave A out of it. When we sample these three, we're only really sampling one channel of data, right? When we sample emissive map, that's going to be RGBA, maybe RGBA. And when we do irradiance map, that's technically a color as well, but it could also be sampled from a cube map. So the reason I bring this up is because, maybe like just having texture maps here isn't necessarily the right move. And that could apply for these other texture types as well, right? Or the other material types, right? So we might want to think about something that's a little bit more advanced than just having a texture map for each one of these things, where we can specify a color or a texture map for that, right? And then we can actually just set either one of those things, and then the shader would have to also be smart enough to know, hey, which one of those things are we actually using? Let's see. So, just thinking about this, what if we were to have something like what if we had a material, I don't want to call it a map. What if we call it a material sink? And the reason I say sink is because we'd also have a source, right? And this is kind of where I'm thinking like down the road a little bit when we have like a node-based material editor. Where a sink would be, you know what, actually, let me do this. Let me find a decent example of what the heck I'm talking about. Okay, let's do... This one might be a good example. Okay. Mm, okay. Yeah, I guess we can use this one. All right. So you've got, consider like what Unreal has, for example, right? We have a node-based editor that kind of looks like this. And this is kind of where I was getting sort of the idea from, right? Where you have this sort of material that's got all these little sockets in it, right? And then depending on what type of material it is, depends on what sockets actually show up, right? And then you can plug things into those individual sockets. And those things can have different sources, right? So for a normal map, this is actually a really good example of what I was talking about, right? For a normal map, we actually have plugged in here a lerp function that outputs a color, right? And so if we look at the A and the B that's in the lerp, right? We have a normal map, and then we just have 0, 0, 1, which is, just one on the z-axis pointing straight out. And so it lerps between these two based off of some parameter that's input, right? And so this is the kind of thing that I'm talking about, like where maybe each one of these individual sinks should support just like some sort of color output. And then that color output is obtained either from a sampler, like a map, or maybe just a straight up raw color, or maybe some sort of function or something. So I don't know that I necessarily want to get this advanced yet, but I almost feel like I kind of want to put this in now while we're like rethinking how this stuff might work. Just to make that a little bit clearer as to what we're talking about. All right. So if we were to do that, and we have a material sink, right? Then what we could do here would be we'd have something like we'd have a texture map, right? So maybe you'd say map, and then we could also have like a vec4 color, right? And then we could also have a like an enumeration, right? So like we could have type def, enumeration, k resource, material map type. Material map type. Right, and so we might have something like k resource, material map type, and then we have or wait, no, this should be material sink type. That's my bad. Right, sink or sunk, that's fine too. So we'd have, for example, vec4, right? And then, or actually maybe we say RGBA, right? And then maybe we have RGB, right? And then RG, and then just R, right? For the different types of vectorized input, right? And then we could also have a k resource material sink type, and we can change this to map, right? And so here we would say k resource material sink type, right? And then based off of this type, it would determine whether we use this or this, and what of this we actually use. Let's see. There's a lot of chat going on tonight. I'm not going to be able to keep up with that. Oh, are you wondering what I'm using? I'm on Arch Linux using Cinnamon. Yeah, it's definitely not Mac OS. I mean, it looks kind of like it, I guess, because of these things, but yeah. No, it's not It's not XFCE. You're on Mac OS. I'm streaming from Mac OS. So my streaming machine is actually Mac OS over here. The laptop sits over here. Didn't even guess Cinnamon. The reason I'm using Cinnamon is because the display that you guys are looking at is a 4K display, but the displays that I have on the side are only 1080p. And Cinnamon is one of the few desktop environments that are X11 based where you can actually drag windows from one to the other, high DPI to like normal DPI, and not have problems with it. So that's why I'm using that. Don't upgrade to macOS 15 yet. They got a nasty networking bug that randomly kicks you offline. Ooh, that would be really bad. Yeah, I don't. As a rule, I don't do major OS upgrades until the 0.1 version or the 0.2 version sometimes for macOS. Sounds like an exciting way to use your computer, right? So, if we set this up, the only thing that is potentially bad with this, and the only reason that I'm considering not doing it now, is that we'll technically have another level of indirection or another level of things we'll have to check. We'll have to check the type of this to see the usage of all of these different things. Maybe that's not such a bad thing, though. Because we do also need to find a way to combine these three things. So I'm just thinking out loud right now. So technically the way this is going to be, like this would be RGBA. This is going to be RGB. This is, whoops. This is going to be R, right? This would be G, and then this would be B, right? If we use the same map, which we're going to get away from that, right? So these three are technically just going to sample the red channel of the texture that they use. Emissive is RGB, maybe A. And then irradiance map is just going to be, I guess, RGB, but from a cube map. So I guess, you know, we would know, like we'd have a little bit more contextual information if we went the sync way. But if we go the sync way, we'd also have to like set up sources that actually hook up this stuff. We probably wouldn't want to. You know what? I'm probably gonna kick myself for this later, but I'm not gonna do this now. I think I'm just gonna leave it, right? Because that's gonna be a whole extra thing that's gonna get in the way, and we don't need it now. So I'm not gonna write it down. But that's what I'm thinking for the future. Okay. So we have the K resource material, PBR. We have these different maps, but I'm thinking we need the combined one, which should be created on the fly. Right now we're just kind of loading it. These really don't need to be separate maps as far as this is concerned, because the K resource texture map actually contains a sampler. So this should be metallic roughness AO map. Right, instead of calling it combined, we'll just call it that. That's a little bit more descriptive. It also tells us what order the things are in. And then when we load up a material and we load the texture data in, we will apply that accordingly. We'll combine those images on the fly. Okay, so I think, let's see, we have Unlit, Fong, and PBR. I think that should be good. So I think what we need to do now is start thinking about removing this material struct and basically replacing it everywhere that we run into it, replacing it with this new guy here. Let's see. So material terrain properties. Materials. Okay, so we are going to have to redo like some of these structures, right? Which is fine. Material fong properties. Like the way that all this stuff is actually loaded is all going to have to change. But that's going to be better in the long run because we won't have to worry about all the complexity that we have now with it. It's actually going to be a little bit simpler. So let's go to, you know what? Let's get this open over here. And over here, in material system, we're going to start thinking about our API, right? Which is, thankfully, there's not that much to it. So the way that this works right now is whenever we acquire a material, we provide a string name. Then this system reaches out to the file system, loads a material with that name, and returns a pointer to that material. And the material system actually owns the material. That's all going to be changing, right? So let's see. So we have acquire, and then we have acquire terrain material, which you give a material name and then material count, and then material names and auto release, right? So again, like a terrain material is sort of this like layered material system that exists, right? But if you notice, it still returns a pointer to a material. So really a terrain material is only a different type of material in concept in terms of like asset, right? It's not actually a different type of material. So we're going to see if we can simplify that a little bit. We also have an acquire from config. So that's like if we set the material config up in code, we can acquire it that way. We have a release, which is by name. So all the materials in the material system are owned by the material system currently. And they are stored in a hash table that has a name lookup, right, as the key. And that's how we obtain that. We are going to switch to k-names for everything. And so we're not going to need that. And then we have get default PBR, and get default terrain. And so we probably we're probably going to wind up keeping these, but changing them up slightly. Noticing the Final Fantasy 13 background music, or 14, yeah. Maybe add bit flags to define what maps exist. Yeah, so that's the other thing is, so right now we have this concept of default maps for stuff. And anytime we don't have anytime we have a material that doesn't have a map assigned, it just uses the default. Which is working just fine, right? We could probably just go in and make some performance enhancements just by removing that stuff. But just read the title. Is this developing a game engine? Yes, from scratch. There's a spammer in the chat named Streamlabs. Time them out. That's funny. Why don't you use Windows? What's the best way to answer that? Because I don't like self-torture. I much prefer working on Linux, for sure. It's just, everything is just much easier. It's much easier working in the terminal. It's much easier to manage files. Compilation's actually faster on Linux too. So yeah, I don't use Windows unless I have to. Of course, the engine's compatible with Windows, so I do have to develop on there for that. But yeah, there's my answer. Out of curiosity, what do you drink while programming? So it's either water or Gatorade, typically. Do you store mesh materials, texture data in the same struct, or do you store them in separate arrays of separate? How do you know which resources to unload when evicting models? Evicting models. When you say evicting models, do you mean like unloading? Gatorade. Like, yeah, Gatorade is what I was talking about. How do you know what resource? Okay, so right now meshes have a reference to a material which has references to textures. So there's a, when I unload a mesh, I also release the references to the material, and I release them. That in turn releases its references to textures. Is that an energy drink? No, it's like a sports drink kind of thing. It's not an energy drink specifically. It's for hydration. So yeah, that's more or less, I think, the answer to your question. Why don't you use OpenBSD? Never tried it, honestly. No particular reason. I don't use OpenBSD because I'm on ARM64. That's fair. You think Mac OS is way better than Linux or Windows? Some people prefer Windows. Yeah, I don't really like Windows. Obviously, I use it because there's lots of software that only runs on it. I prefer Linux because I can hack it to my desire, and I have done. Can't really do that as easily with Mac OS. There are ways, but I have all three here, and I prefer Linux the most. Mac OS is behind that, followed by Windows. For me. Yeah, because I prefer star Nix platforms. Exactly. Yep. Every time I go to Windows and I go into the command prompt, I just start cursing. What theme are you using on Cinnamon for this colorful buttons? That falls under the category of GFQ. I don't remember. Where even is that? Let's see. I guess it's literally just the cinnamon theme, apparently. Let's see. I wonder if it's coming from Adwaita or C Black, maybe? Like, this is literally what I'm looking at. So I don't remember which one that comes from. I set this up a long time ago. I agree, Oxycook. Yep. They're all annoying in their own unique ways. Yeah, you're not wrong about that. I have to admit, ARM64 Windows 11 can run a 32-bit game, x86 game, written in 2001, and it runs out of the box. Can't say that about Linux or macOS. I have never tried ARM64 on Windows 11, so I can't speak to it. Eventually one day, but yeah, I already built another computer on the stream earlier this year, so I'm not going to be doing it again anytime soon. It's amazing, it's stanky fast. Yeah, that's how I feel about my M1. Oh, let's see. Okay, so I guess let's start with the acquire and release. So what we're going to do here is we're still going to call this name, but we're going to change this to kname. And we're going to change this to kResource material. And we're going to do the same for this. Oops. We're going to do the same for this. But we're only going to take material name. And we're going to come up with some sort of way to be able to trigger, the sort of multi-loading of materials. So this is probably going to take some doing, because I think we kind of hacked that together a long time ago, and I think we probably need to revisit that. Another thing we should do is we should probably specify auto release, right? So did we not even put that in here? We didn't. All right. So what auto release is basically saying when a reference to the material is released, if the reference count is 0, its resources, if I could spell right, are automatically released, freed, we'll say. All right, so we need that one here. Put that here. Okay. So what this does is pointer to the loaded material can be a pointer to the default material if not found. I don't know if we should do that, actually. We should probably just like return null pointer. If found. Otherwise false. And then use, it should be up to the caller to say, hey, if we weren't able to load this material or acquire it, then go ahead and, you know what? I'm going to get rid of this auto release, actually. We're just going to have materials auto release by default. I'll get rid of it here too. Let's just simplify this API a little bit. So we'll leave it up to the caller to say, hey, if we don't get anything back here, use whatever default material you need to use. So we'll do that. We'll do that here. If found. Otherwise, 0, no. And this should be 0, no. All right. So there's that. Let's just check the comment here. Attempts to acquire terrain material with the given name. If it has not yet been loaded, this triggers loading, blah, 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 blah. You know what? These are kind of the same now, aren't they? Let's treat them the same. Right? So we're just going to say load a material. And if the material that we load has a flag in it that says, hey, I'm a terrain material, and I actually reference these other 4 materials, that should be in the actual terrain file, and figured out by this before we actually do anything else. I think that's, yeah, that makes more sense. Okay, so acquire from config. Let's see, do we want this either? I don't see why we should be creating a material in code, to be completely honest. Because we're trying to get away from the material system owning materials, right? We want the resource system to handle that. So I'm actually going to remove this as well. Nuking more code. All right, so material system release. This one is going to be, this is going to be the K resource material pointer to the material itself, right? So releases the given material. Decreases reference counter by 1, reaches 0. The material is unloaded, releasing internal resources. And we'll get rid of this and. All right. So there's that. And then this is just now material, a pointer to the material to unload. Right? Okay, so this should be a constant pointer whenever we do this. So we should have const k resource material, and we'll just do the same here and there. And then this should be constant pointer and a constant pointer, right? Because if we get a default material, then we should be we should not be able to modify that, right? Also, this default should be unlit. Right, and then we also have fong. Does not reference count. Yep, okay, and then PBR. And we no longer have terrain. Right? We're not going to have a default terrain material. Or maybe we should, actually. But it's not going to be like a separate type of material. It's going to be just like a different instance. So we're going to say get default terrain PBR. Right? And we're only going to bother creating a default PBR terrain. Thank you for the follow. Appreciate that. Welcome. VS 2022 boots up in about 2 seconds. Man, I would have to see that to believe it. Because that's a big steaming pile, if you know what I mean. There's a reason I don't use it anymore. Wait, is that you in the profile picture? The glasses match? Yes, it is me. It's a very old picture of me, though. But yes. Yeah, I used to be relatively clean-shaven and short hair. But that has changed over the years, right? So that picture was from my wedding back in 2012. So that's quite an old picture. And I had short hair then, but I've had long hair before and after that several times. So I'm actually growing my hair out now. It's not very long yet, but what I do is every few years or so, I grow out my hair, and then I grow it out to at least where I can cut off 12 inches of it and donate it to cancer patients. Because I've lost a few people, close relatives and loved ones to cancer. And so what I do is my way of sort of trying to help that is I donate my hair, right? And so I'll grow it out for a couple of years, and then once it's long enough, I'll cut it off, donate it, and do that. Obviously can't do that with this, right? But that's why this hair is getting long, is because I'm growing it out to donate it. But yeah, this I never had a long beard before this, so people on the stream have been saying I'm not allowed to cut it until I release the first game. But yeah, that's more or less the explanation there. Does Linux do this to everyone? Make the beard full grown? I think so, especially once you switch to Arch Linux, by the way. I wish hasn't worked for me yet. Yeah, I could never have one when I was younger because of the jobs I held and stuff like that. But now I work remotely, so it doesn't matter. Let's see. Do only meshes and terrains use materials? For right now, yes. But also other things that'll use it will be. Let's see. We'll also have, eventually I'm going to convert the water to actually use materials. And then obviously our skeletal meshes will use materials. And then other, different surface types will use materials as well. Zug Zug. Um, let's see. I remember being 10 years old, asking my mom to buy it and being underwhelmed by it. I assume you're talking about Gatorade. Yeah. Um, I mean, it's okay, but I drink it for the hydration portion, right? That's a great thing to do. Sorry for your loss. No, I appreciate that. Yeah, you know, it's a tiny thing that I can do, but my hair is actually quite nice when it grows all the way out. I've been told that, so I figure, yeah, I can at least maybe it'll be made into to like a wig or something for somebody that can't grow it out. Um, Zag Zag's such an important message. Yeah. Apothemy use Arch. Nice. Switch to Arch. Yep. Um. Yeah. No worries. Okay. So let's see. Where were we? And then we have material system dump, which dumps the names of all the register materials and the reference counts handles. I don't know that is that. I don't know as if we really need that anymore. And that would be actually kind of hard to track with the way that our resource system works now. We should probably re-implement that. So I think what I'll do for now is I'll put in a fix me, find a way to query this from the K resource system. Oh, that's funny. It picked up on the bug text and like highlighted it. Because it says KDebug. That's very funny. Let's just change this to trace to get rid of that. Oops. All right. Okay, so we'll do that. And I think that's going to do it for our API as far as how that needs to look. As far as the system initialization, that can stay the same. So can the shutdown, at least from the interface perspective, right? We don't need this anymore. Let's see. And we also don't need these default names anymore because we're not using strings for that anymore. So we don't need this, right? Guess we might as well update this to 24. All right, so let's go to material system initialize. And let's see, how many lines is this file? 1,000. Okay, so this file's getting ready to be a lot shorter. Because all this stuff around reference counting is all going to go away. So I guess let's get the function signatures changed first. So kname name, right? That's going to be that, and then we have kResource material. I'm not going to worry about these for now. I'll come back to those. We're just going to change the function signatures. Material system acquire reference. Okay, so this is what handles our internal reference counting, right? So guess what? Gone. Acquire terrain material. This is going to be the same thing, right? So this is basically looping through and getting resources. I'm just going to, let's see, You know what? I'm going to nuke this one too. And we're just going to handle this. We're going to handle this all in one shot. So we're going to get rid of this. Acquire from config. We're also getting rid of. Don't need that. Release. Oh, wait. We take the material here, don't we? K resource material, pointer, material. Okay, so there's that. And then we have get default. So we had, let's see, what was it? And actually, this one just returned the default PBR texture also. So this is going to be a K resource material, and that was const, actually. So we've got that. And actually, we need to go up here to our actual internal state and create some default materials. So this is going to be default unlit and default Fong material, then PBR, then default terrain. The other thing is these are going to be K resource material, and they are going to be pointers, right? Because they're not going to be owned by this any longer. While we're in the state, let's get rid of some stuff. So this register materials, gone. Register material table, gone. Why do we have shader stuff in here? I'm assuming probably for mapping. So we get it there. Shader instance resources acquire. Okay. So we can leave that for now, but we're going to have to come back to it. Because we definitely want to remove all those. Let's see, Radiance cube texture. This is stored in the material system, and that doesn't really make a whole lot of sense. And I'll explain why. So what we're doing here is we're keeping a pointer to sort of the global irradiance cube texture. And really that ought to come from the scene, right? Like where we have an irradiance map set in the scene, or an environment map, right? That could ultimately be used for that. It should be up to the scene to define that. Because maybe the scene even has more than one, depending on where we are in the scene, right? And so that shouldn't be there. Shadow texture really shouldn't be there either. That should be there, or defined by the scene. Thank you for the follow. Appreciate that. Oh, Willow Tree, thank you so much for the Prime. I appreciate that. Thank you very much for the support. That means a lot. Thank you. Thank you very much. It's very much appreciated. Do we even use this anywhere, or did we actually factor this out already? So we do set it here, and then it's never actually used. Okay, so we must have already factored that out. So let's get rid of that. Okay, the shadow texture might wind up actually being the same thing. Okay, that's shadow textures within the material itself. So that's same thing. So that's actually not used either. That can go away. Directional light space, I think this is going to be the same thing. This used to do a lot of stuff with shaders. And yeah, see, we only have these defaults that are set here, and then they're not actually used, so that can go away too. This used to do a lot of stuff with shaders, and now it doesn't. And it looks like I've just not removed a lot of stuff. So we're going to make this a lot more lean and mean. We do keep pointers to these systems for quick access, so we do want to keep those. So this is all we actually have to store in here now. It's just some pointers to some default materials. These eventually are going to be removed, and then some pointers to renderer and texture system states, and then a copy of the config, and that's it. Right? So if we take a look at initialize, so we actually have struct requirement, array requirement, and hash table requirement. So none of those are needed anymore. So this actually just becomes this, which can be simplified to that. And that's all we need for the memory requirement. All right, so PBR shader ID is invalid ID. For now, we're going to keep that. That's eventually going to get clobbered as well. We don't have any hash table stuff anymore. That's gone. We don't need this. We don't need any of this. We don't keep track of any of that stuff anymore. We don't need this because we get that there. So these eventually are going to be removed. Right. And then we have some default materials that need to be created. And then we register a console command for material system done, right? So what we probably ought to do is like rethink this when we go to create the default materials. We'll think a little bit about how we want to handle the unlit and Fong versions of this. We'll probably wrap this all into a single function that gets called from here, and then move that further down the file. So that's the initialize, a lot simpler. The shutdown. The shutdown is we don't actually have to do this. And actually, we do need to destroy default materials. These are no longer owned by this, though, so we have that. Destroy material. That must be an internal function. It is. So let's do k-resource material. Do the same thing there. All right. So we'll destroy the defaults. Obviously, we'll have to add some more to that. All right. So the acquisition of a material is now going to have to reach out to the k-resource system, which did we? I don't think we actually saved off the state for that. No. So we should do that. State resource system. And then down here, we'll do state resource system equals engine systems gets whoops, that should be k-resource state. Right. Okay. We should probably also, instead of calling this repeatedly, which is kind of dumb, we'll do a const engine system states. We'll call this states, right? And then we'll just do that, and then that. All right. So we have all the systems we need there. And so what we'll have to do is, instead of getting a resource out of the old resource system, we'll need to get a resource system out of the new resource system. And then we have this acquire from config rubbish. And then we unload the resource, right? So this is where we're going to have to turn to the resource system to actually kick off loading of the resource, as well as giving us or kicking off the asset loads and all that stuff. So we should be able to do k resource, and then k resource, well, I guess we'll call this, I guess we could just call this out resource. Thank you for the follow. I'm 24 and you taking the Zug Zug comment seriously and reading it out loud made me laugh. I should add Zug Zug for sure. I recognized what it was. That's why I read it out loud, because it's super funny. What advice can you give for finding remote work? I want one, but I haven't been able to find one, and I've applied to a lot. I don't know if I have any advice specific to that. I guess got lucky. The only thing that I can say is you should be able to prove that you can definitely like work on your own without supervision and not have to be like, constantly like supervised. That's kind of a hard thing to prove, but like if you have a track record of that from previous employers, that would help. But yeah, I mean, I hate to say it, but I really don't know of any advice I could give that's specific to that, to finding something like that. Like I said, I just kind of lucked into mine. Do you have any advice on how to get better at SIMD? Feels like if you mess up SIMD even a little bit, like you do a couple too many loads than needed, you just lose versus the simple scalar implementation. And another question, is it provable that all code in a loop can be vectorized? And would we typically expect that to perform better? I've tried to see if I can just say in my head if I'm not better than the scalar version I messed up. Okay. Well, I would say my answer to the second question is the only true way to test that is profile it, right? I mean, you can think about all the theory you want, right? And think about, what compiler optimizations might be out there and this and that. But really none of that means anything without actually, looking at the disassembly and or profiling it to see if it is indeed faster. Do you have any advice on how to get better at SIMD? I think it kind of is like, SIMD is a weird thing, right? Because you don't have to touch it that often. Like like once you figure it out and you get it working, like you just kind of, it's like a set and forget. So whenever I do SIMD stuff, I always have to look stuff up. I always have to like reread manuals and like look at the spec. Because I don't do it often enough for it to ever really be something that sticks up here long term. So yeah, I don't know. I mean, the best I can say there is look at solid examples of it running really fast. Like GLM has some really good examples of SIMD, for example. That's probably one of the better examples out there. And look and see what they do. But yeah, I mean, again though, if you're comparing SIMD against just simple scalar implementations, again, like profiling is key. And testing it with and without compiler optimizations is also key. I hope that helps. I realize that's kind of nebulous, but Grim Heartless, how's it going? It's been a bit. Always awesome to see the view count this high. Yeah, I appreciate that. very much. It did help. Thank you. All right, awesome. I'm glad. Like I said, SIMD isn't something that I have to touch that often. So it's like when I think about it, I'm like, okay, let me go refresh my memory on this again. I actually haven't tackled it in here. I need to tackle it in here. Probably not for the first game, but eventually we are going to be tackling that. So thank you for the follow. Appreciate that. All right. All right. So out resource is k resource. Oh, you know what? It's probably not going to. Let's do this. Include systems k resource system. So we're going to do a k resource system request. The state is going to be state pointer. We have to get rid of that to resource system. We're going to pass through the name as it is, and then we have to do a k resource request info. Speaking of which, that is something that we don't have yet for. We don't have that defined for our materials, so we're going to have to actually define that next. So let's just do, for right now, we'll just say k resource request info, and we'll change this to material request info, right? And we'll just call it request, right? And then we'll pass here, since that's looking for a pointer, we'll pass request, right? Obviously that type doesn't exist yet, so we're going to have to create it. So in resource types, I believe we have something for texture. So I'm just going to take this and sort of use it as a template. And actually this is going to be quite a bit simpler. So this is going to be material request info. Okay. Now, as far as we don't need any of this stuff, as far as actual properties for a material request, I don't think we actually need anything specific. But I'm creating this structure anyways, so that we can add to it later on if we need to. I realize that its only member is the base, right? I've realized that. But this way, we don't have to like change, to this structure and create it later on. We can just add to it when we actually have something that we want to use. So we'll just create that for now. And all it's going to contain is the name. So this is going to wind up being k resource request info. Pointer, right? So we'll just cold cast that, and then we'll have our out resource. And actually, in terms of acquisition, that's it, right? So all this stuff here, see ya. All we have to do is return out resource. Now, I realize I could just return right there instead, right? But when you're debugging, it makes it a little bit easier if you have it on a separate line. So we'll do k resource material pointer. So we'll cold cast that again, and then that's all there is to our acquire now, right? So all of the reference counting, all the auto release stuff, all that stuff is all handled by the resource system. The only thing that we'll have to do is fill out the request. Base type is going to be k resource type material. And I think, was there anything else in there that needed? Let's see, we have types. We don't care about a listener instance or user callback. Well, maybe we do. In fact, yes, we do. Because when this is loaded and brought in from disk, and we have all of our properties, we're then going to have to cycle through the material itself to get a handle on what actually is... Well, let me think about that. Should we do that here, or should we handle that in the handler? I feel like we should handle that in the actual material handler and keep this simple, right? We want to keep this like the user code simple. And incidentally, for release, all this poop here, gone. All we have to do is k-resource system release, and then we'll do state pointer, resource system, material, right? And we'll have to obviously cold cast that to a k-resource pointer. And that's all there is to releasing, right? Diamond, how's it going? Good evening to you as well. We're doing pretty well here. We've moved past the texture stuff. Now we're into materials, and we're sort of redefining the way that materials work in the system while we're at it. Because this has been something I've wanted to do for a while, and now this is a good opportunity to go ahead and just do it. So we're able to actually remove a lot of code out of the material system. In fact, we've removed about 300 or 400 lines so far of code. So yeah, it's we're removing more code than we're adding, which is pretty sweet. Cool flippin' beard. I appreciate that. Thanks. First time chatter. Welcome, by the way. Been implementing a pool and arena system for my game, and Zig comp time makes it such a breeze. Yeah, I bet it does. I wish C had comp time, but I also don't want to step up to C23 to get it. All right. So for this, we have the unlit. Let's see, we have unlit. This one should return state pointer default unlit material, right? We have that. Then we have default Fong. Wow, completely butchered that. Okay, default Fong material. Default PBR, this is going to be a const k resource. If I can spell material. And then I'm actually just going to do away with all those checks and just do that. Thank you for the follow. I appreciate that. Welcome. I can know what types I need to make pools and stores. Yeah, that makes sense. Hi, hey, hey, yo, yo, hey, hey, and all that stuff to everyone. That's a great welcome. No problem, Streamlabs bot. Yeah. I put that in there because sometimes I miss like follow events and stuff. So it makes it a little easier for me to see. Okay. All right, so terrain material is going to be the same thing. I'm not going to bother with these checks either here. We're just going to do that. Now, one thing that I did want... Oh, you know what? Okay, so a lot of this stuff is going to be going away too, or we're going to simplify that. I think, though, before we do that, I want to get rid of this state pointer business everywhere. We should be passing in the state into these functions as we call them. So like here, how we do this, like we pass the state, I want to do that here. Put it in the right spot. Right? We want to take in we want to take this in. Why did it only... There we go. Okay, so we want to do that. And then... do that. And the advantage there is that we can get rid of the stupid... oh, did that just... that's not what I wanted. There we go. We can get rid of that stupid static state pointer. Because we could just pass the state here wherever we use it, which we can easily get from anywhere using the engine systems get. So if we go back to... let's see. Material system state. Right, so we just do this here. Do that there, and then instead of state pointer for these guys, let's see, actually this needs to be... Oh, it just replaced it. That's not what I want. Right. And acquire is going to be the same thing. Okay. Now we can get rid of... where was that? We can get rid of that stupid thing. And come down here, get rid of that. And just call state everywhere. Much cleaner, right? Okay. So most of the work is actually going to be, oops, I can get rid of this too. Most of the work is going to be down at the bottom of the file where all of these like map assignments and things happen. We're going to see if we can't like clean this up a little bit and simplify it, because there's a lot of kind of repeated stuff that happens in here that we really don't need, you know, multiple copies of. It's kind of ridiculous, to be completely honest. Another cool thing I implemented recently is I store all configs as a custom binary that the game can load as a struct during debut and keep a file watch and in release embed it as a static struct without external file dependencies. Yeah, that's pretty sweet. I actually thought about doing something kind of similar to that myself. I was thinking for release, for the application configuration and release, I was thinking about like literally taking the executable file and like jamming the data on the very end of it, and then just keeping somewhere a reference to like where exactly that is in the file, or just, you know, counting backwards. It's nice to just change parameters while the game is running. Yeah, and we're gonna have that once we have hot resource reloading for sure, which is another thing we need to build in. We're gonna want that during game dev for sure. Maget how's it going? Good to see you. Stretch, it's good for you. Yeah, thank you for the stretch redeem, by the way. Ooh, my back just cracked. Oh, I love when that happens. Oh, it just did it again. Sweet. I don't think you guys can hear that, but yeah, it was a loud pop. Let's see. Playing my favorite game of all time, Deus Ex Human Revolution. I don't think I've played that one. I played the original. The one that was on like Unreal 2. Also got my engine running on Linux. Sweet. Yeah, those are satisfying. Yeah, super satisfying for sure. The original is very good. Yeah. Yeah, the original Deus Ex was amazing. It looks terrible these days. But yeah, it was really good for its time, for sure. Way ahead of its time. All right. So all of this stuff happens when we load a material. Now I'm thinking that we might just come through here and maybe look into, how we can kind of reuse some of this stuff. For example, we've got all this stuff about properties in here, all of our maps and stuff. We have this material type PBR, which I think is pretty much the whole dang function. We have custom in here too, which we never wound up utilizing. You have a lot of logic for that. Yeah, and that's basically the rest of the function, right? So I might actually remove like some of that custom stuff because we don't use it, and I have a feeling I'm going to change that anyways when we actually go to have like our sort of node-based editor. Want to do something similar, love the simulation nature, people keep finding new things from it. Yeah, I've heard about that. Thank you for the follow, by the way. Thank you very much. Appreciate that. Welcome. We have several new followers tonight, actually. So actually, you know what? I'll take a quick second because we're gonna have ads here in a second anyway. So let me just take a quick second for all the new people. And introduce what we're working on. So what we're doing is we're building the Kohi game engine is what it's called. And it's a game engine that is written in C, and we're building almost everything from scratch. And we're using Vulkan as our initial rendering backend. And I say initial rendering backend because we have plans to support Direct3D and Metal as well. It is cross-platform, so it runs on Windows, Linux, and Mac OS, with other platforms planned in the future. It started off as a YouTube tutorial series that was basically like just a step-by-step tutorial. But as with any project that goes sort of past the tutorial phase, you kind of outgrow that format. And with something as complex as a game engine, we outgrew that pretty quickly. So we outgrew that. We changed formats a few times, tried a few different things, ultimately landed on the live stream format that we have here on Twitch and YouTube. We simulcast to both. With that, the website that we are looking at, by the way, is kohiengine.com. I'll drop a link in chat to that. This is a open source engine, so there is on this website there is a GitHub link at the bottom of the page, and you can see here that this is free and open source. It is Apache 2.0 license, which means that it is free to use either independently, personally, commercially, whatever. The only thing that I ask is that you say that you used it if you use it. There will never be any sort of licensing or royalty fees of any kind ever. It will always be free and open source. There's other links on here, including YouTube, Twitch. We have a Discord server that's rapidly approaching 1,000 users. GitHub, and of course a Patreon if you want to support my work that way. And of course the live stream here at the bottom. And that is pretty much... that's pretty much where we're at, right? So we're going to have ads here in just a second. I like to pause the stream whenever ads come up so that nobody misses any content. I don't always catch them, but I try to whenever I notice that they're coming up. What's that map called in your screenshot? Oh, I didn't show screenshots, did I? So let me go here. I assume you're talking about this map. That's the Sponza map. That's kind of a common test mesh, right? That is used. It's got like 400 submeshes in it. So we have a basic PBR lighting model that we use. This is kind of a dated screenshot at this point. Both of these actually are, but we have cascading shadow maps, the ability to drag and manipulate objects in the world. We do have UTF-8 font rendering, things like that. Yeah, Panamos, no problem. First time chatter, by the way, welcome. So yeah, that's pretty much it. And there are the ads. So as I said, I like to pause the stream whenever ads come up. And on Twitch, that's once every 30 minutes for up to 90 seconds, depending on region or locale. And so I just like to pause the stream so that nobody misses anything. And hydrate. Steve, have a good night. Appreciate you being here. 4:40 a.m. That is late or early, depending on how you look at it. But yeah, have a good one. Thanks for stopping by and interacting. Have a good one. About 30 seconds left on ads, and then we can continue. Almost done with ads. No ads? Yeah. So depending on region or locale, you might not get any ads. Sometimes you'll get like 15 seconds worth of ads. Some people will just get a banner. It varies depending on platform, region, locale, a whole bunch of different things. And if there's an ad to fill that slot, you'll get one. Otherwise, you won't. So yeah, I like to pause based on the lowest common denominator, which is that 90-second number. That most people would probably get, just so that nobody misses anything. All right, so what we're doing here is we are in the middle of refactoring our material system, and we're aiming to leverage the new resource system that we set up in order to actually load our materials, and then in terms of managing them, the resource system will also reference count for us. So we had a lot of logic in here that we were able to remove because of that. So we're kind of in the throes of that right now. So the other thing that we're doing is the state pointer thing was sort of a private static variable that was a pointer to the state. We're getting rid of that too, just because it'll assist in hot reloading if and when we do that for this library. Okay, so I guess the next big chunk that we're going to have to handle is this load material. So what this does is it returns a boolean to indicate success or failure. It takes a pointer to a material configuration, and then state. So this configuration has things like the version of the material, the name of the material in string format, the material type, the shader name if it's like a custom shader that it uses, and then some material config properties and maps for configuration, and then auto release, whether or not it's supposed to auto release. So this is sort of the old configuration that we were using for our old style of materials. And then these structures over here are our new style of materials. So we really ought to set up like I guess, let me just go to definition on this. We really ought to set up a new sort of material config to work off of that is set up a little bit differently. So let's call this k resource. Actually, you know what? Wait a minute. Material config. Do we even need that? I don't actually think we do. So part of what we're switching away from is a lot of our systems kind of handled resources and assets as one thing, and now they've been split apart. And a lot of systems themselves were actually responsible for setting things up. And now that we have a resource system with different resource handlers, a lot of that work can be offloaded to those. So let's actually take a look at the material, handler material. And that's the asset handler. Oh, we don't have a resource handler for this, do we? Okay. That's the piece that's missing. Okay, so texture. So if you recall, like the work that we've been doing, we had this sort of texture handler, which was responsible for taking the texture asset that was loaded or pixel data or what have you, and setting up an image based on that. We need to set up something similar to this for our materials, and I thought I had done this, but apparently not. So this is a missing piece, not that big of a deal. But a lot of stuff that is in our material system is actually going to wind up being offloaded into one of these. And so we should actually probably start there before we go anywhere else. And so what this will give us is this is going to give us the actual loaded material, the material resource. And so all that stuff that is in the material system about loading materials and all that stuff is all going to come out of there. The code looks very coherent. I love that. That's awesome. You didn't get ads either? Yeah, not everybody does. It varies. Thank you for the follow, Alumino. I appreciate that. Most people that I know that have great beards are 10x programmers. Is it a thing in tech? I guess. I don't know. This has only been within the last year or so that I've actually grown it. If you look at my profile picture, I barely even have like a little thing here. Thank you for the follow, by the way. I appreciate that. Welcome. All right, so let's write a resource handler for materials, right? And then that will actually spit out one of these guys. So to do that, that is going to be under runtime. Where did we put this? I think under K resources handlers. Okay, so we actually only wrote the texture handler. All right, so we're gonna have to write the handlers for all the other types of resources too. Thankfully, textures was the most complicated one. Materials is the next most complicated one, like less complicated than textures. And then meshes after that, and then everything else after that is far less complicated. So thankfully, this won't be too bad. K resource handler material, and we'll do H, and then C. And I'm actually going to go into this H file for a second and just copy pasta and open up this, paste, and then we're just going to do renames on these guys. Right, so these are pretty standard stuff here, so there's not really much to really go over there. And then let's go into the C file. All right. All right. So we'll get that. And let me space this over a little bit. And I'm gonna do this same thing here. All right. I've really got to fix that error at some point that pops up, but the thing works anyway, so I'm not really that worried about it. Okay, so this needs to be a resource material. So essentially what this does is this is sort of a standard entry point to say, hey, give me a pointer to a resource that is of the size that you need it to be, right? In our case, that's going to be a resource material. Let's see. That may not always be correct, though, because we can have different types of materials, right? We can have the unlit material, we can have the Fong material, we can have the PBR material, all of which are different sizes. So we almost need like a parameter of some sort in here. But we won't know that until we actually fulfill the request. That's an interesting problem. We didn't have that with textures because textures are always kind of the same size, but this can vary. So we might have to rethink this a little bit. So the way that the call order for these handlers typically works is the allocate was called first, and then the block of memory that's called here is passed into the resource here. This performs the request, which basically says, hey, asset handler, give me an asset for this based off of this information here. And then it returns true on success or false on failure of the asset request, right? The asset request is instantaneous, but asynchronous, right? So it returns immediately, but issues a callback when that actual load from disk is completed or whatever. And so we'll have an immediate result as to whether or not that request was able to be kicked off, and that's what we return here. But we won't know until that asset is actually loaded as to what kind of material it actually is. Which means the order that we're doing this thing in here is not going to work. So I might have to rethink how we do that, right? Because either we do it that way, or we perform the allocation as part of the request. Well, no, that wouldn't even work. That wouldn't work either, because that asset load is asynchronous, and we're not going to know the type till that comes back. But we need to immediately return a pointer to a resource. Sikelos Music, how's it going? Good to see you. Welcome, Steffi Sott, by the way. Thank you for the follow. Coherent, yeah. That's probably one of my favorite puns so far. We are getting some good puns today, though, for sure. Yeah, it was... Yeah. Coherent. It's coherent code. Okay. So I guess that technically means... Because if we take a look at this, we're never going to be just dealing with one of these, right? We're always going to be dealing with that plus an unlit, or plus a Fong, right? Or plus PBR properties, right? And they're all different sizes. Plus, we're going to have, additional other types that will exist in the future. So now I've got to think of a way that maybe will be a little bit better suited to how this works. Now, one thing that we could do, we have some properties that are like kind of repetitive between these, right? So we have, we may have to go back to we may have to go back to a properties and arrays type of. Because materials is really the only place where this happens. So one thing that we could do is include in the K-resource material all of these maps, and then only just use some of them based off the type. That's one solution, right? And then we just switch based off of this type. Or we have an array of texture maps. But then those would also, that was kind of the problem. That was kind of the thing I wanted to get away from, is like we have an array of those and then we have to hold on to indices of those things, like what we're having to do in the material system now. And I kind of want to just be like material dot diffuse map, right? I kind of still think that maybe adding all the possible properties under K-resource material, under this base type, is going to be the way to go. Right? So if we do this, right, and then we have, I'm just pasting them in here. I'll adjust the comments in a second. In this one. Let's just put it here, right? We'll eliminate the dupes here in a second. So if we do this, I'm just going to comment. Actually, you know what? I'm going to nuke this because we can't use that. So diffuse color, diffuse map we already have. I suppose we could rename this one to albedo diffuse map because they kind of serve the same purpose, right? So maybe we do that. And maybe that's just the way that we go. And then we say, you know, if it's unlit, the only one that we actually reference is this guy. If it's Fong, then we reference that one, and that one, we'll say. Right? If it's PBR, we do these two, and these two, and this one. And then we also have, like, that property, which isn't accessed, right? I guess that makes sense. Right? And we'll just have a switch statement in the code that handles it, right? So we'll say Fong only for this one, for example, right? And I'm not going to bother commenting all these until we figure it out. But that would at least make the model work. Yeah. I think that makes sense. Okay, so that'll fix that issue. And then for material request, I guess we can, you know, kind of model it after this guy. So we can do, we can probably go ahead and grab this stuff. All right, we need logger. And this is going to be handler material. Okay. This is going to be a material. And this is going to be a material. And then we have info assets, right? So we need to check if info assets base length, in other words, the number of assets we have listed in here, is less than 1. That's an error. K resource handler material request requires exactly 1 asset. Which actually, this should probably be that. Okay. And the reason for that is one material will be linked to 1 asset. Right? We're not going to have in a single request like this multiple materials, right? We're just going to have one. It's a one-to-one relationship. Now, in the event of a terrain material, the terrain material config will actually have other assets listed out, which we would then kick off another request similar to this. So that should be fine. So actually, I think, believe it or not, I think we can actually do this. Right. I think that's it. Right. Okay, so couple things we need to do. We do need to set up a listener instance with a callback as to when the actual thing is, when the actual asset is loaded. The reason we need to do that is because that will then allow us to set up all the properties of the material, create the actual material, fill it out, and then kick off the texture requests and set those pointers up as well. And set up all of the texture maps and things of that nature. Let's see. Quick distraction. If you have a specific book you pull out anytime that someone asks for a recommendation, what's the name of that book? I'm guessing you're probably talking about this guy, because it's the one I hold up almost every stream. There it is. Game Engine Architecture by Jason Gregory. Thick boy. 2C's thick. I think it's that one. Is that the one you're thinking of? All right. So we'll make this, let's see. Let's copy pasta this. All right, and we're going to do material resource handler info. Which we don't actually have that. So this is going to be essentially a struct to hold some listener info for our callbacks to have some context, right? So we're going to have a material. We're going to have a handler, which is going to be the handler itself. We're going to have the material material request info, the original request info. And then the assets themselves, which is going to be, let's see. All we actually are going to have here is a single asset. So we're going to have a, this is going to be a k asset material asset, right? Pointed to that, or pointer to that rather. We don't need a loaded count because we're only dealing with one. Let's see, that should be 7s material. Okay, so we've got that. So we allocate one of those. This is material request info. We take a copy of that info. We set the typed resource. Typed resource is up here. So we have that. We set the handler. We don't need a loaded count. We do need the asset. Let's see. Actually, this is just going to be asset equals 0. Okay. And technically, we don't even need to iterate this array, right? Because there only should be one asset, right? So actually what I'm going to do is I'm going to say info assets sub 0. Should be data. And I'll need the address of that. Okay. So we have that. We don't have any import params actually. This go around. And then we have material k asset on result, which we have to write. So this is the listener instance is sort of a context that gets passed along with the asset system request that contains pointers to the things we need to know about. And then this is going to be the callback as to when that asset is actually loaded. We call that function to passing along this context object along with it to say, hey, we know, or this has been loaded. Go ahead and process the thing. Do what you need to do. So we need to do, I'm going to just declare this for now. And again, I'm just going to copy pasta this. I'm going to bat away the ads for a minute here. And this is going to be material and what is this bleating about? Oh, just not defined. Okay, that's fine. All right, so we've got that hooked up. And so if the image type is, or the asset type is material, you know what, we should probably, we don't even need to actually verify that. That would have been verified for us by the resource system when it was selecting a handler. So that's, doesn't even need to happen. Okay, so asset info. Okay, so we have that, and at this point, the asset system request would have been kicked off. At this point, we can just return true, because we didn't hit any errors, right? So we should be good as far as that goes. And then what will happen is when this asset is loaded, this callback will be made, and then we can go ahead and process that. I think, see, textures are way more complicated than anything else. Let's take this. only because there's some bare bones code in here, or skeleton code I want. So let's do define that. This is going to be, the listener is going to be that. Fix that type. Okay. So, if the asset request result is a success, then that means that what we need to do now is take a look at the asset that is passed in here, convert it first of all to a material, and then we're going to do assets data, and whoops, in this case it's going to be sub-0. Or actually, it's not even, that's right, we didn't even use an array there, it's just going to be asset, right? So we set that. We don't need the loaded count. And then here is where we actually do all the loading stuff, right? So this, let's see. Yeah. Okay, so let's see. This... Yeah, this whole section can go. All right. So, failed to load required asset for material resource. All right. And then, let's see, destroy the requests. This should be... of the correct type. Okay. I'm not so sure that this actually is even correct, because we should always destroy the request. Yeah, we always need to destroy the request when we're done. I'm going to keep this label here just in case we have an error condition that we need to jump to. So what I'm going to do is do to do, and we're going to say setup copy over properties of material, then request texture resources from the texture system. And that's going to be the next thing that we're going to work on. And so you can see why we attacked textures first, right? Because this relies on it, fonts rely on it, terrain relies on it, right? So the fact that that work is already done will make this a lot easier. All right. Let's see. Reminds me of my music history book from college. Really only interested in the audio part, but I'm having a hard time finding resources. Been learning how to use, is it Juice? J-U-C-E? But it's not really giving me the depth I'm interested in. Not that I plan to write an audio engine, but I'd like to better understand how things work. That's fair. You could also look into OpenAL as well. You think Twitch is pooping itself? Hopefully not. Oh, it's happening to all you guys? Well, yeah, I know it was happening earlier, so. Let's see. Yeah, it does say it's unstable. I think Twitch is pooping itself. I think over on YouTube we're good. Very strange. Yeah, it does say it's unstable. All right, well, at least I have all this recorded, so it'll be uploaded to YouTube anyway. All right, well, tell you what, let's go ahead and use that as a reason to go ahead and raid. I'm going to end this here for tonight, and we're going to raid. let's see. Tonight I'm just going to raid Alveus Sanctuary. So yeah, I'm guessing, yeah, it looks like my bit rate on Twitch is like through the floor, but it's fine for YouTube. So I don't know what's going on there. But anyways, thank you guys so much for the raid, or for being here rather. And we're gonna raid Alveus Sanctuary. So let's see, when's that gonna kick over? How about right now? All right, we'll see you guys later on the next stream. See ya.